Hi, this will be the first part in a hopefully multi-part series on the Math 30-1 Diploma Exam. This one is January 2019 and you can find it online. I'll probably include the link in the description. But I'll just be going over each question one by one and I'll try to do it in an informative and simple way. Okay, question one has to do with transformations. We start with a function y equals b to the power of x where b is greater than 1. And we end with a graph that's y plus 3 equals b to the x plus 1. Now, this doesn't look like the form that I'm used to, so I'm going to switch the 3 over to the other side by subtracting. So we're going to end up with b to the x plus 1 minus 3. Now we can go ahead and explain what's going on in words. So this x plus 1, it's a shift, a translation, 1 unit to the left. And the reason it's to the left is generally whatever you do to the x, the opposite looking thing happens. And we'll see more of this show up later on. And then the negative 3 is pretty intuitive. It's a shift downwards of 3 units. So we start at 3, 8. We shift leftwards 1, so we get 2. And we shift downwards 3, so we get 5. And that's why the answer is B. Next up, question 2. We're given that a function has a domain between 2 and 6 and a range between -4 and 8, and then it undergoes this transformation. And all this comes down to really is being able to describe this transformation correctly. So first of all, what is this negative sign doing here? Since it's on the outside, it's actually acting on the y. So what this negative sign is a vertical reflection. Okay? And then this half x, since it's acting on the x, the opposite thing is going to happen. So instead of halving whatever value you have, it's going to be a 2 times horizontal stretch. Okay, and then now let's just apply this to our domain and our range. So the horizontal stretch applies to the domain. So we have 2 is less than or equal to x is less than or equal to 6. If we stretch this by 2, we're going to end up with so multiply 2 by 2, we get 4, and multiply 6 by 2, and we get 12. So we can already cross off B and C from our answers. Next up, we should do the vertical reflection as well on the range. So the range started at -4 is less than y is less than or equal to 8. So then, if it's a vertical reflection, all of these are just going to become negative. So this will become 4. So y is between 4 and -8. And then the signs, it doesn't make sense to say y is greater than 4, but less than -8. So obviously we just have to switch the signs here. And we end up with y is bigger than -8, but less than 4. And the only answer that looks like that is D. Question 3 is one of those questions where you just have to go through each option one by one and see which one makes sense, see what doesn't work. So first of all, let's just look at A. So A is a 2 times, is that a 2 times stretch? No, it's the opposite. So it's a 1/2 stretch in the horizontal direction. So I'm going to put 1/2 H stretch for horizontal. And then it's a translation upwards by 10. And for these sorts of questions, I like to use the endpoints because you can see them. They're directly on the graph, and you can see where it should go. It should just go to that point right there. So first of all, we have to do a 1/2 horizontal stretch. This looks like it has an x-coordinate of 5, which means a 1/2 horizontal stretch is going to be right there. It's going to be 2.5, and that's clearly not in the right spot. So we can just cross off A right away. So this one, f of 1/2 x plus 10, that is, so it's the opposite. It's not a 1/2 stretch. It's a 2 times horizontal stretch. And then we're going to go up by 10. So once again, so this 5 becomes, so it's multiplied by 2 because it's a 2 times stretch, and it becomes 10. And then it goes up by 10. So that's not the right location. We wanted it to just stay right there. So we can cross off B as well. Next, we're going to look at C. So C is a 2 times vertical stretch, and then a 1/2 times horizontal stretch. And so let me just erase here to make some room. So if we start at 5 here, let's do the vertical stretch first. Nothing happens. So since the y coordinate is 0, 2 times 0 is 0, so it stays there. Then the 1/2 horizontal stretch moves it here. So that's wrong as well. So the answer is D, but let's see why. So first of all, it's a 2 times vertical stretch again. And then it's a 1/2, or sorry, my bad. So it's the opposite. It's not a 1/2 stretch, it's a 2 times horizontal stretch, which makes it go from 5 times 2 to 10. And then the 2 times vertical stretch, once again, 2 times 0 is 0, so it stays in the right spot, which makes D the correct answer. Question 4 is a little more challenging, just because there's a lot more to do, but if you just do it slowly and methodically, paying attention to detail, it's just as simple as all of the other ones. It's just more steps. Okay, so first of all, you have to notice that this is in the incorrect form. So we have 1/2 f of 3x plus 12. Generally, we want whatever's inside of the f to be factored. So what's the greatest common factor here? Is just 3. So we factor out the 3, and the inside just remains as x plus 4. And then the outside is still minus 1. Okay, it doesn't look as pretty, I know, but it's going to help. So let's begin to describe each transformation. So this 1/2 on the outside, since it's on the outside of the f, it's acting on the y, and we can just describe it as it is. So it's just a 1/2 times vertical stretch. Next, we have the 3 on the inside, so we do the opposite since it's acting on the x. So it's a 1/3 times horizontal stretch. Then we have this plus 4 on the inside. We do the opposite, so instead of going to the right 4, we go left 4. And then on the outside, we have this negative 1, so we're just going to read that off as just negative 1, so down 1. So the point that we're starting with is negative 3, 4. Then we apply this 1/2 vertical stretch, and it becomes negative 3, 2. We're just dividing the 4 by 2. Then we apply the horizontal stretch, the 1/3, and it becomes negative 1, 2. Finally, we translate to the left 4, we get negative 5, 2. And then downwards by 1, so negative 5, 1. And that's why the answer is C. Question 5 is asking for how many points would be invariant when this graph, this weird wiggle, is reflected in the line y equals x. So first of all, let's just draw the line y equals x. So y equals x is going to have a negative 6, negative 6. It's going to have 6, 6. It's going to have 0, 0. It's going to have 1, 1, 2, 2, 3, 3, etc. I'm just going to draw a line here, and hopefully, yeah, that looks like it lines up. Okay, and now what are we looking for? We're looking for invariant points. And when we're dealing with a reflection, an invariant point, let's just try out some points. So for reflecting this point about this line, it's going to end up there. If we're reflecting this point about this line, it's going to end up there. It's getting closer and closer to the invariant point. If we reflect this point along this line, it doesn't change. And that's what an invariant point is. So essentially, all this boils down to is how many times does this weird wiggle intersect with our line y equals x. And we can just look at it and see. So it's going to intersect right there. It's going to intersect right there. And that's it. So that's 2 intersections. All right. Next question. Read it carefully. It's going to sound like gibberish, but pay attention. So a restriction on the domain of the graph of the quadratic function f of x equals just the general form that would ensure the inverse of the y equals f of x is always a function is, and then it gives you a bunch of domain restrictions. Now, how can you possibly tell this from just a bunch of letters, right? This is why I like to draw graphs. So, whatever, that's my quadratic function. And what we want to know, we want to make sure that the inverse is always a function. Now, what does that mean? It just means that, when we inverse this, so when we inverse this, it's going to look something like this. So this is not a function because, well, if I ask you what's f of 0, you're going to be like, oh, f of 0, that's 2, or whatever that negative value is, negative 2. A function can't have more than one value at one point. So it's not a function. You'd have to restrict its domain to something like right there. So do you see how you can solve this problem now? So all we're doing is we're splitting the parabola in half because we don't want the bottom half. The bottom half, makes it not a function, makes the inverse not a function. So we need to split off the bottom half of the inverse, or the left or even right half of the parabola. And what are the options that it gives us? So it gives us x is greater than 0. So that would be like right there. That doesn't matter. It doesn't matter if it's x is greater than 0 or less than 0. What about x is greater than a? A is the stretch factor. That doesn't really make sense. So we can cross off that one, cross off that one. So what about c and d? C and d are the coordinates of the vertex. So right there. So that's c, d. And c is the x coordinate and d is the y coordinate. And since we're dealing with the x coordinate here, obviously we want to deal with the c, like the little c. So we choose big C as our answer.